So today we're talking about transformations of the quadratic function. And we've talked about transformations in the past. A transformation is something that changes the position or size of the graph. So we've talked about translations in the past, where that moves it from side to side or up and down, perhaps both. We've talked about dilations, which make something narrow or wider. And we've talked about reflections in the past. And so we'll talk about all those today with the quadratic function. Remember, the quadratic function is just something that is y equals x squared. That's actually going to be our parent function. And it comes, of course, with a parent graph. So if I wanted to make that parent graph, I'm going to have my coordinate plane. Its vertex is at 0, 0. And if I wanted to make a chart to graph my x's and y's, I not only have 0, 0, I have 1, 1, negative 1, 1, 2, 4, negative 2, 4, 3, 9, negative 3, 9, and so on. And all I did to get this t-table is I plugged in these values of x and got these values of y. But when I go to graph that, here's maybe 1, 1 and negative 1, 1. And if I go 2, 2, 4, negative 2, 4, and so on. And I'm going to get this graph that I can draw a curve through. And it does touch that bottom point at 0, 0. But that's going to be my parent function. Okay? So translations will move my graph in different ways, and we're going to take some time to explore what ways, well, that didn't work, it could move it. So let's get started. So the first one we want to talk about is vertical translation, so moving up and down on my graph. And vertical translations have the form y equals x squared plus some constant k. And that constant k, we have two scenarios. If it is greater than 0, meaning it is a positive number, my graph moves up. Up is a positive direction. That makes sense to us. And how far does it move up? Well, it moves up the absolute value of k units. So if k is 3, it will move up 3 units. If k is less than 0, my graph is going to move down the absolute value of k units. Okay. So for example, if I had f of x, and remember f of x is just another way to write y. If I had f of x equals x squared minus 7, we would say that would move down 7. So try this one on your own. We'll say g of x is another f of x kind of thing, is 5 plus x squared. See if you can tell me what direction that moves and how many. Good, you should have gotten up 5 units. Okay? So then we want to talk about horizontal translations. And horizontal translations have the form y equals the quantity of x minus h squared. So if you see it with parentheses and then squared, we're talking about a horizontal transition. And horizontal transitions are a little funky just because instead of, like on vertical, it was plus k, this is a minus h. So you have to kind of figure in that is to which way you're going to move. If h is greater than 0, our graph is going to move right. Again, the absolute value of h units. And if it's less than 0, we're going to move left, the absolute value of h units. Okay? So, and when I say it's tricky, here's kind of why. So let's say, for example, we have g of x equal to x minus 3 quantity squared. Well, it looks like a -3, but remember our form is supposed to be minus h. So really that h is equal to 3, which is greater than 0. So our graph is going to move right 3 units. Okay? Try this one on your own. We'll have g of x equals x plus 2 quantity squared, and see if you can tell me which direction that moves and how many units. Good, you should get left 2 units. Okay? Sometimes it can move both up and down and horizontally. And what that will look like is, let's say, for example, we have g of x equals x plus 2 quantity squared plus 3. So I can do it in any order I need to. I see that plus 3 tacked on, so that it gives me an up 3 units. I also see this plus 2, and I know that's supposed to be minus h, so really that's going to tell me to move left 2 units. Okay? Why don't you try this one on your own? We'll have x minus 4 quantity squared minus 4. So you're going to move 2 different directions. Good, you should have picked down 4 and right 4. So the next kind of transformation we want to talk about is a dilation. And dilations make the graph narrower or wider than the original. And it takes the form g of x equals a times my x squared. So maybe you're used to seeing something like 2x squared, blah, 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 blah. Like that's when it's going to make the graph either narrower or wider. So we have a couple options here. We take the absolute value of a. If the absolute value of a is greater than 1, so whether or not a is positive or negative doesn't play so much a factor in how it stretches. The positive or negative just plays in which way it opens, either up or down. If it's greater than 1, it's a whole number greater than 1, or even if it's a fraction greater than 1, the graph is going to stretch vertically. If it is a fraction that is less than 1, the graph is going to compress vertically. And I have always had trouble with that terminology, stretches vertically, compress narrowly. Like vertically, what does that really mean? If it's stretching vertically, it is becoming more narrow. It is compressing vertically, it's becoming wider. And to kind of show you what I mean here, let me go ahead and draw a coordinate plane. And let's say our parent function is this orange one, and that's y equals x squared, okay? But we'll say this one, this green, is compressing vertically, or widening. If it's compressing vertically, I'm pushing at the top down, and I'm going to flatten it out so it becomes much more like this. So it's a lot shorter, it's compressed vertically, but you're widening it out. Versus stretching vertically or narrowing, I'm pulling up those ends so that it becomes really tall and thin. So that's what a stretching vertically would look like. So let's talk about some examples. Let's say I have j of x equal to 2x squared. Well, the absolute value of this 2 in front is 2, and that's greater than 1, so this is going to stretch vertically. Try this one on your own. H of x is equal to 5x squared minus 2. So you're going to have 2 graph transformations there. See if you can tell me what they are. Good, it's going to stretch vertically. but is also going down 2. And just for giggles and grins, we'll do one more. We'll have 1/3, or I'm sorry, I should probably put g of x equals 1/3 x squared plus 2. So again, we're picking 2 transformations here. Good, it should compress vertically. And go up 2. So the last transformation we want to talk about is reflection. So if my pink graph is my parent function, the orange is the reflection, and we've kind of already talked about this, what makes a graph flip across the x-axis. And it has something to do with the a value. So would a positive a or a negative a make the graph flip across the axis? Good, a negative a. So a negative f of x would open down. And sometimes that looks like, let's say for example, we have the function f of x equals negative x squared plus 9. So this has 2 transformations going on. One, it's reflected across the x-axis because of this negative here. But I also have that plus 9 tacked on, which means it's going to move up 9. So I've got a couple more examples here that we're going to play with different ways this could move. So let's try another one. We'll say h of x is equal to 2 times negative x quantity squared minus 9. And the reason I put the negative in with the x is that you can see it reflects across the x-axis. It also has this 2 in front. That's going to have something to do with it stretching. So I need to know, does that make it stretch vertically or compress vertically? Good, it should stretch vertically. And then I also have that negative 9 hanging at the end. And of course, that moves it which way? Good, hopefully you picked down 9. So let's play with maybe 2 more examples where I have a couple transformations. So we'll start with g of x equals negative 5 minus 4/3 x squared. And I don't have to include the negative with the x squared like I did here. It could be just hanging out in front over here. So I have 3 reflections, or 3 transformations rather, that are going on with this example. Let's see if we can pick them all out. So hopefully these are the transformations you picked. This negative in front of the 4/3 makes it reflect across the x. The negative 4/3, the absolute value of that is greater than 1, so it stretches vertically. And of course, this negative 5 hanging out in front, I could move it to the back and say it's negative 4/3 x squared minus 5, but it is still going to move it down 5. And this last example, I have h of x equals 1.35 times the quantity, x plus 1 squared, plus 2.6. And I know there's some decimals here, but we're not really graphing it, we're just telling how it'll move. So let's see if we can pick out 3 transformations that are happening here. So my transformations that are happening, I'm going to go, I have this plus 2.6 at the end, that moves me up 6. This plus 1 moves me left 1. And this absolute value is greater than 1, so I'm going to stretch vertically. Thanks for watching.